Okay, now we're really getting into the heart of the trigonometric identities. Because what we're going to do now is take all of those identities, those cofunction, Pythagorean, odd, even, quotient, reciprocal properties, and we're going to start putting them all together and putting them to use. Now, the first thing I recommend that you do, go to the module, print out the identity sheet, okay, so that you have all of these there handy for you. Eventually, you're going to have to do it without the sheet. But for now, you're going to want to use this like a lifesaver because it's going to give you all of the process and answers that you need. It's just like if you had all of your geometry theorems and postulates right here together in one place. So, with that, we're going to simplify some trigonometric expressions. What we're going to do is, for all intents and purposes, we're going to do a big O proof. So over here I have my statements. Over here I have my reasons. Now, in this case, it's not going to be entirely like a proof because all we're wanting to do is simplify this. We want to break it down as much as we can. And whereas a proof gives you a given and it tells you where to go, a proof, in this case, we're just going to try to break it down, make it as simple as we can. Again, just like geometry, there's going to be slightly different ways you can go about this. Your answer might be done in a different order as someone else. You might use one type of property. They might use a different type of property. But in all cases, we still need to be able to do the following process. Whatever your statement is, the reason is given. And if you do the homework without telling me what statements you're doing and showing me every step of the way, you will not receive credit. Just like a geometry proof, I need to see it all. In this case, if I want to simplify, I'm going to look at this and say, all right, what properties might potentially apply, in this case, to help me simplify? Now, in this case, the first thing I'm going to notice is that I have cosecants and secants and tangents, and yuck, that's a whole lot of stuff. One of the things that I suggest to make trigonometric solving easier, at least to start with, this won't work all the time, but to start with, what if we change things around a little bit? What if we gave them some sines and some cosines? Now, in this case, I have cosecant. Cosecant, using the reciprocal property, is 1 over sine x, times secant, which is 1 over cosine x, minus tangent, which is sine x over cosine x. Now, I have to give a reason for what I've done. I used two reciprocal properties, and I used one quotient property. Now, so now that I've said what I've done, I look at this and say, well, I have fractions. And I can't put fractions together by subtraction unless I have a common denominator. So what I'm going to do is get a common denominator. I'm going to multiply top and bottom by sine x over sine x so that this denominator and this denominator are the same. That gives me 1 minus sine squared x over cosine x sine x. That is nothing more than fractions, folks. Nothing more than fractions. And my reason is I found common denominators. That's my reason. Now, I look at this and I say, wait a minute, I don't see that property here, but Mr. Moore told me that I needed to add two properties to this sheet. Sine squared theta equals 1 minus cosine squared theta, and cosine squared theta equals 1 minus sine squared theta. I warned you in the previous video that this was the property that you would see over and over and over again, and I have a 1 minus sine squared, so that equals cosine squared. So I can replace this whole deal, substitute cosine squared theta or x, whichever the case may be, over cosine x sine x, and my reason would be Pythagorean property. Now, I have how many cosines up top? 2. I have how many cosines in the bottom? 1. So I'm going to cancel 1 out of the top and 1 out of the bottom, leaving me cosine x over sine x. And what did I do there? I simplified. You could have said reduced, could have said divided by cosine. That would have been all fine. And finally I say, wait a minute, cosine over sine, that's adjacent over opposite. This whole thing is equal to cotangent of x. And cotangent of x, changing a cosine x over sine x, cosine x over sine x, that's a cotangent of x. And there we go. So that is a quotient property. So the reason here would be quotient property. So I have now done a simplifying proof, okay, giving all of my statements and all of my reasons. You must give me both sides or you will not receive credit. Now, in this case, I use two at once. Normally, I suggest you only do one step, one property at a time. But in this case, it was fairly clear-cut which way they went. So, you went from this whole mess all the way down to there's your answer there. That's about as simple as I think I can get it. All right, we're going to take a look at another one. Okay, let's give this one a whirl. We're going to start in example 2. I got example 2 and example 3. Let's deal with example 2 first. Hopefully at this point, after seeing the last problem, everybody should see the very first thing I ought to do, and it is put given. Now, the first step to actually solving something is going to be what? Well, I take a look and I see 1 minus some squareds, or some squareds minus some 1s, so I'm going to say that looks a whole lot like a Pythagorean identity. Do I have any of those guys up here? Well, I have 1 minus sine squared. That looks like that. So I'm going to replace this right here with cosine squared theta all over cosecant squared theta minus 1. And that's using a Pythagorean identity. Now, the next thing is say, ooh, I see cosecant squared theta minus 1. But up here, ooh, I don't have any of those things. Could I replace cosecant squared theta with cotangent squared theta plus 1? By, again, Pythagorean theorem. Now, having done that, I can say, well, what's plus 1 and minus 1? Those go away, leaving me cosine squared theta over cotangent squared theta. That is by simplify. Now, at this point, I have cosines and I have cotangents. So I probably ought to change things into sines and cosines. Well, cosine squared theta over, and this ends up being cotangent, that's adjacent over opposite. That is cosine squared theta over sine squared theta. That would be by the quotient property. Now, I have a fraction inside a fraction inside a fraction. So, let's multiply top and bottom by the reciprocal. Sine squared theta over cosine squared theta. Sine squared theta over cosine squared theta. That's nothing but fraction rules. Cancel, 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 cancel. Cancel, cancel. I'm left with sine squared theta. And that's going to be by simplify. Now, sine squared theta is about as far as I think I can go. So I'm going to call that simplified and good. And I've taken this all the way from here down to here. Now, by the way, there are other ways to solve this, different orders, different properties, different uses of fraction. So yours may not look exactly like mine, but the idea is it should be close. All right, let's see if you can do example 3. Now, in example 3, I don't have a Pythagorean theorem. I don't have a cofunction. I don't seem to have an odd even. In fact, I don't seem to have much at all, except that I have something over this minus this over this. So I can break it into two fractions. Secant x cosecant x over secant x cosecant x. Well, that's kind of nice. I like that. Minus tan x over secant x cosecant x. And that's nothing but fractions. Okay? Now, this cancels out, leaving 1. That is super duper useful. Minus, now, in this case, I kind of have a whole pile of mess. Because I have tangents and secants and cosecants, and I don't see any properties that connect them just like that. So, let's take a look at changing tangent into sine x over cosine x, all over, secant turns into 1 over cosine x, times, because it's times between them, 1 over sine x. And so now, what do you think I'm going to do? Well, hopefully if you figured out that every time you have a fraction and a fraction, oh, by the way, that was by quotient and reciprocal, that I'm going to multiply by the reciprocal. Now, first of all, I'm going to multiply top and bottom by cosine x sine x over 1, cosine x sine x over 1. Those cancel. This cancels. And so by simplification, I come up with 1 minus sine squared x, because I have a sine times a sine. And that's by fraction reduction. You could call it simplifying fractions, multiplying by reciprocal, either one of those you want. At this point, I want you to tell me what is the step that goes right here. And that is going to be cosine squared x. And now I need you to give me a reason. It is Pythagorean theorem. And that's about as simple as it gets. So, with that, let's see what we can come up with as we move forward. Okay, ladies and gentlemen, I have 3 more example problems here, but I'm not going to do them for you. I want you to go ahead and do them. But you can take these. You need to have them ready to turn in. And even if you do something wrong, I want you to write them down. I want you to attempt something. I want you to attempt something, even if it makes it worse, even if it makes it bad. I just want you to try something. This simplifying trigonometric functions and simplifying expressions is not going to be easy, especially for those of you that like to say, just tell me what to do. This is not a just tell me what to do kind of issue. This is something just like geometry and proofs where you're going to have to figure out lots of different methods to get to where you want to go. You have to take the entire sum of what you know and apply it to the problem at hand. For some of you, that's not going to be pleasant, but it is something that we have to do. So, with that, give these 3 a whirl, bring them to class.